Well, you can convert between the two. We'll talk about that later in more detail. But 1 radian is approximately 57.3 degrees. Now, I don't want you to remember the approximation. We can come up with an exact measurement, but for reference purposes, you can remember 1 radian is about 57 degrees. So you can have 2 radians, that's 2 times 57, roughly right about there. You can have 3 radians, that's almost pi radians, 3.14. And you can keep going around the circle. Now, if you go all the way around the circle, the angle that you have is 2 pi radians. And that's the circumference of the circle. 2 pi radians is the circumference, right? Because the circumference, C, is equal to 2 pi r, where r is the radius. Well, r is 1 on this circle, so C is 2 pi. So when you go all the way around, you're going a distance of 2 pi units. That's the circumference of the circle. So 2 pi radians would be equivalent to 360 degrees. Now, a half revolution would be pi radians. That's 180 degrees. A quarter revolution is 90 degrees, or pi over 2. That's half of pi, and so on. So, again, a little basic review here. The arc length S on the unit circle is the same as the radian measure of angle theta. Now, we can convert between the two using a formula. 360 degrees, we said, is equal to 2 pi radians, 1 total complete revolution around the circle. Therefore, 180 degrees equals pi radians. And so, to make conversions, you multiply by 1, where 1 could equal 180 degrees over pi, or you could write it as pi radians over 180 degrees, depending on what you're converting. The idea is to cancel out what you originally have, cancel out the units of measure that you originally have, and change to the other measure, which is similar to what we did converting degrees, minutes, and seconds to decimal degrees. So, for example, 0.18 degrees, I multiplied that by 1, and I chose my 1 to be 60 minutes over 1 degree and put the degrees in the denominator so I could cancel out the degrees here and change that to minutes. You would do that similar thing with this. So, for example, 120 degrees, let's say. I want to change that to radians. So you multiply by 1, except which one of these do you use? Well, you use this one because the degrees are in the denominator. I want to cancel the degrees out and change it to radians. So I multiply 120 degrees by pi divided by 180 degrees. And the degrees will cancel, which is what I want, and I'll get an answer in radians. So that's 120 over 180 pi radians. And that can be reduced to 2 pi over 3. 2 pi over 3 radians, which is about 2.1 radians. But we prefer the exact answer in mathematics, so that's the way I want it. Alright? And that's the way I want to see it on a test. So don't give me a decimal approximation. Now, if you do this on a calculator, which you can do, you can convert between the two with a calculator. I want to convert 120 degrees to radians, so I would enter that on my calculator, press D arrow R, that means change degrees into radians. Press that menu choice and I get 2.0944 roughly, and that's basically what I have here. Alright, but I'm getting a decimal approximation. Again, I don't want to see that on a test. You can do that as a check of your work, but I don't want to see that answer on a test. Alright, so I want you to be able to do this the way I've done it here. Alright, you can go the other way. For example, let's change negative 297.2 to negative, or rather, let's go the other way around. Excuse me. I want to change 3 pi over 4 radians to degrees. 3 pi over 4. Change that to degrees. So put the radians down below and put the degrees up above. So multiply that by 1, which is 180 degrees over pi radians. Alright. Cancel the pi's out, of course, and what you have then is 3/4 times 180 degrees. And that equals approximately, or rather exactly, 135 degrees. Alright. So, again, you can do this on a calculator, and I would just press R arrow D on mine. Yours might operate differently, though. So you'll have to look at your user's manual. But again, I want to see an exact answer if at all possible. Now here's one where you're not going to get an exact answer. Let's say 8.5 radians. I want to change that to degrees. So I multiply by 1, but make that 1 equal to 180 degrees over pi radians. And so this is equal to 8.5 times 180 over pi, or 8.5 times 180 degrees rather, over pi. And this one requires a decimal approximation. That's about equal to 487.01 degrees. So sometimes we do want the decimal approximation because this is easier to work with than this. Alright. Oh, by the way, you'll notice when I wrote radians here, I didn't put any units next to the numbers. Well, that's because radians don't have units. So the word radians is optional, and usually it's omitted. So for example, pi radians is just pi as a real number. And so if no unit is given for a rotation or an angle, then the rotation is understood to be in radians. Alright? Now, let's talk about finding coterminal, complementary, and supplementary angles in radians. So let's find a coterminal angle with 2 pi over 3. 2 pi over 3 radians. Now there are many answers possible. Again, you think of 2 pi over 3 radians and rotate 360 degrees to either clockwise or counterclockwise, or more than 360, multiples of 360 in either direction, and you'll get a coterminal angle. Now 360 is 2 pi, so we're working with radians, so we have to stay in radians. So rotate 2 pi degrees. So you're going to add or subtract multiples of 2 pi instead of 360 degrees. So I could take 1 times 2 pi and add that to 2 pi over 3, and that equals 2 pi over 3 plus 6 pi over 3, getting a common denominator, and that gives me 8 pi over 3. So there is a coterminal angle, 8 pi over 3 radians. Alright, and that's coterminal with 2 pi over 3. Or you could go the other way, go clockwise and subtract 2 pi over 3 or multiples of that. So let's go 3 times around here, going the clockwise direction. So I'm going to subtract 3 times 2 pi from 2 pi over 3. So that equals 2 pi over 3 minus 18 pi over 3. Getting a common denominator, and that equals negative 16 pi over 3. So this angle is coterminal with 2 pi over 3. What about complements and supplements? So let's take the angle pi over 6 radians. What is the complement of pi over 6? Well, in this case, we're talking about angles that add up to 90 degrees, complements. 90 degrees, though, is not what we want to use because we're dealing with radians. So, again, you must be consistent with your unit of measure. So, you change 90 degrees to pi over 2 radians. So, what I want to do is subtract pi over 6 from pi over 2 to get the complement. So, pi over 2 minus pi over 6 is equal to 3 pi over 6 minus pi over 6. And that equals 2 pi over 6, which equals pi over 3. So pi over 3 is the complement of pi over 6. What about the supplement? The supplement of pi over 6. Well, you want these angles to add up to 180 degrees this time, but again we're dealing with radians, so 180 degrees is pi radians. So you go pi minus pi over 6. And pi is equal to 6 pi over 6. So that's 6 pi over 6 minus pi over 6, which is 5 pi over 6. So 5 pi over 6 is the supplement